Example 2 and 11.2 deals with another combination, and it talks about writing a geography exam. Then the instructor says that she must answer a specified number of questions from each section, not in any order. She just has to, answer 2 of the 4 questions in part A and 3 of the 5 questions in part B. Now, right away, it is telling us how much is in each part. I'm going to write that down. That there's 4 in part A and there's 5 in part B. So when we look at, section, or I guess, I don't want to say part A. If we look at the first part of example 2, then if she's answering 2 of the 4 questions in part A, that's 4 choose 2. And I'll just put an A underneath there. And then she's also going to select from part B 3 of those 5 questions. And that's going to be 5 choose 3. Now, one of the things that I think is important, at least to talk about at this point, is that if you do have your calculator, I encourage you to check and see that 5 choose 3 is the same thing as 5 choose 2. And the logic behind that is when I'm selecting the 3 questions to answer in part B, I'm effectively also selecting the 2 questions not to answer. And there's a particular formula that comes up with combinations, and it's n choose r is always equal to n choose n minus r. So just a couple different examples. Let's say we had 20 choose 17. This would be the same thing as 20 choose 20 minus 17, or 20 choose 3. There's a question in the textbook that asks you to kind of prove that. And it's a really good question about kind of manipulating factorials and looking to do some cancellations. But it is something that's an important concept, that this isn't true for permutations. It's only true for combinations. That we are either picturing this as choosing what to be in the selection, which is the same thing as choosing what's not to be in the selection. There should be the same possibilities in either of those cases. As it is, to solve this question, I'm going to figure out 4 choose 2 and I suppose 5 choose 3, and then we're going to multiply them together. So 5 choose 3 in part B, there are 10 different ways that she can make those selections, and 4 choose 2 in part A, there are 6 different ways that she can make those selections. So there is effectively 60 different exams that she can, or different types of exams that Rihanna can answer. All right, for part B, it gets a little bit tricky. It introduces this at least concept. It says she must answer 2 of the 4 questions in part A. Well, that's not bad. We already did that, right? We did 4 choose 2 in part A. And then it says at least 4 of the 5 questions. Well, if it says at least 4 of the 5 questions, she could answer 4 of the questions, or she could answer 5 of the questions, all the questions really. And I really try to use that language really specifically. I said or in there because she is going to make, answer 4 of the questions in part B. And I'm going to say that this is my first case. Case 1 is that she is answering 4 of the questions in part B. So that would make this 5 choose 4. So in case 1, 4 choose 2, we already calculated that. It's 6. 5 choose 4. And this is what's nice about knowing how to use that form. 5 choose 4 is the same thing as 5 choose 1. And n choose 1 is always n, right? If I have 5 items, there's 5 ways to make that selection if I'm choosing one of them. So I'm going to put a 5 there, which means there are 30 different ways that she could answer 2 questions from part A and 4 questions from part B. But it's not the only thing that she could do. So there's also another case. There's a case 2 here. And in case 2, she's going to answer 5 of the questions in part B. Now, she's still answering 4, or I guess 2 out of 4 in part A. But now in part B, she is going to be answering all of them. So 5 choose 5. Now, if you throw that into the formula, that's fine. 5 choose 5 will always be 1. And the reason for that is because order doesn't matter. 5 choose 5 is effectively saying how many ways are there of making all the items part of your selection? And there's 1. You select all of the items. So in case 2, when she's answering 5 of the questions in part B, there are 6 different ways to answer the questions in part A. There is only 1 way to answer all the questions. So there are 6 different ways. Now, I am going to write that if you put at least 4 from B, you have to consider that that's 4 from B plus 5 from B. Right? That's an either-or situation. I can do either of those situations. Well, there's 30 different ways to answer 4 of the questions from part B, and there's 6 different ways to answer 5 of the questions from part B. So there are 36 different ways to answer at least 4 of the questions in part B. At least or at most do tend to confuse students a little bit. Try to picture it as, you might have to write out what the at least or at most would be. If I wanted to tell you, I'm rolling a dice and I want to get at most 3, then I could roll that dice and get a 1, a 2, or a 3. So there'd be 3 different possibilities, or I mean 1 from each case, and my chances would be 3 out of 6 to roll at most 3. All right, I'm just going to put up, oh, I missed an example there, so I'll stop this and we'll do that third example in another video.